Avogadro's number is an important number in chemistry, and many people already know that it is this actual number here, 6.02 times 10 to the 23rd. It's a really huge number, right? So we typically use it for really tiny things like atoms, molecules, ions, but it can be used to count anything. And it's the number of items in a mole. Doesn't matter what it is, it's that many things in a mole. Just like no matter what it is you're counting, if it's a dozen, there's 12 of them. Doesn't matter if they're big, small, in between, heavy, light. If it's a dozen, you always have 12 items, right? So if you have a mole of something, doesn't matter, big, small, heavy, light, in between, you always have this many items. So in the ALEKS problem, we're dealing with some different sized items, okay? And in this problem, we're going to be looking at raindrops. And we're going to say how many moles of raindrops are there in the Pacific Ocean. Now, the Pacific Ocean is an enormous place, and raindrops are fairly small. So this isn't a bad use of the idea of moles. So let's look at this and see what we can come up with. Well, first of all, we're going to notice that the units aren't the same. We've got milligrams and we've got kilograms. So let's fix that first, okay? So a raindrop is 50 milligrams, right? 50 milligrams is how much a raindrop weighs. So let's change that into grams. And we're going to change milligrams to grams. So how many milligrams are in a gram, or how many grams are in a milligram? I think it's easier to always think about the small thing and the big thing, instead of saying how many big things are in a small thing. Then you have to use decimals, right, and fractions. Let's talk about how many small things are in a big thing. That's much easier to think about. So of these two, milligrams is smaller. And so how many of the small things are in the big thing? Well, milli means a thousandth. So we're going to put 1,000 small things in the one big thing. And then we're going to do the calculation, come up with this answer that a raindrop weighs 0.050 grams. All right. How about the Pacific Ocean? Okay, Pacific Ocean, big old place, right? How much does it weigh? All right, so let's look at that. That is 7.08 times 10 to the, what was it? 20th kilograms, right? And so we need to change kilograms to grams. Now let's do the same thing. Let's think which one's bigger, kilograms or grams. In this case, kilograms are bigger than grams. Kilograms is something you can weigh yourself with. Grams are smaller than a teaspoon. So if you think about a teaspoon of water, the smallest spoon that you have in your kitchen drawer, that small spoon, there's about 5 grams of water in that teaspoon. So that's a pretty small measurement. But yet, if you go to Europe or almost anywhere else in the world and you step on a scale, it's not going to weigh you in pounds, it's going to weigh you in kilograms. So that's a much bigger unit than grams. So kilograms are bigger than grams. And again, the unit is 1,000, but the prefix means thousand, but this means thousand, not thousandth. So we have 1,000 of the small guys, and this time grams are the small one, not the big one, in the one. So we're going to change this and come up with 7.08 times 10 to the 23rd grams. That's how big the Pacific Ocean is in grams. That's how much it would weigh. So looking back at our problem, the first thing it asks us to find is the mass of 1 mole of drops, right? So we have figured out the mass of 1 drop in grams. So let's take that, 0.050 grams per raindrop. And then we know, because of Avogadro's number, that we have 6.022 times 10 to the 23rd raindrops in 1 mole, because there is 6.02 times 10 to the 23rd anything's in a mole. Raindrops, books, atoms, it doesn't matter what. It's always this number of things in a mole, right? And now we can look at our units, and I can cancel raindrops and raindrops, and we're going to have left grams per mole, right? The raindrops are gone, and I'm going to have left 3.0 times 10 to the 22nd grams per mole. And we can call this really the molar mass of raindrops. Because what is molar mass? It's just the mass of a mole of those objects. So the molar mass of copper is what is the mass if you had a mole of copper atoms. The molar mass of carbon dioxide is the mass of if you had a mole of carbon dioxide molecules. Well, the molar mass of raindrops is the mass if you had a mole of raindrops. So this can be called the molar mass of raindrops. All right, that's part one of our problem. The second part is it wants to know how many moles of raindrops we would have in the ocean. So now that we've got our molar mass, we can use that to figure out step 2 of our problem. So the second part of our question is asking us for the number of moles of raindrops in the ocean. So let's look at what we know about the drops in the ocean. Well, we know that all the drops in the ocean weigh 7.08 times 10 to the 23rd grams, because we calculated that, right? That's the mass of all the drops in the ocean, because that's all the water in the ocean, but the water's kind of composed of drops. So that's the drops in the ocean, right? And then we can use the molar mass of the drops, raindrops, 3.0 times 10 to the 22nd grams is 1 mole. So my grams cancel, moles is left. That's going to be my unit, my answer, right? So I'm going to have moles as my answer. And then all I've got to do is punch it into a calculator, and the answer is 24 from the calculator. So I have 24 moles of raindrops in the ocean. In the Pacific Ocean, I should say, because that's the ocean that we were given the data for. So 24 moles of raindrops in the Pacific Ocean. Oh my gosh, raindrops are small, the ocean's enormous. Moles must be an awfully big number. That kind of confirms that thing that we already knew. That's a big number. All right.